Substitution is a method for evaluating some integrals, and a typical situation is when two functions are given, say for example the cosine function and the function x squared plus 1. We can compose those two functions, so we have cosine of x squared plus 1, and when we multiply the result by the derivative of the inner function, so by 2x, this is a typical function that can be integrated by the method of substitution. So to evaluate this integral, our substitution u is going to be the inner function, which is x squared plus 1. And then we'll take the derivative of this function u with respect to x. So the derivative of this function is 2x. And then we multiply formally both sides by dx. And we get that du is 2x dx. Then this factor 2x dx, this factor in our function, we're going to replace this by du, and the inner function x squared plus 1, so this function will be replaced by, this inner function will be replaced by u. This is going to be u. So when we do so, we get that this is equal to integral of cosine of u du, and we know that this integral is the function sine of u plus some constant c. And so we get that this is sine of the inner function was x squared plus 1 and plus the constant of integration c. Here's a similar example. The inner function is still the same, x squared plus 1, but that's not exactly the derivative of the inner function. It's derivative up to a constant. We can still integrate such a function by substitution, and we'll let u to be x squared plus 1. That's the inner function. Then we'll take the derivative of this function u with respect to x. So the derivative of this function is 2x. And then we multiply formally by dx, we get that du is equal to 2x dx. And then we divide both sides by 2, so we get half of du equals x dx. In our function we have 17x dx, so we multiply both sides of this by 17. So we get 17 by 2 du equals 17x dx. And now we can do the substitution. So this is going to be integral of the function cosine of u, and then the 17x dx, this factor will be replaced by 17 by 2. So 17 by 2, and then du. So this is a constant, we can pull it outside. So this is simply going to be equal 17 by 2, and we have this integral of the function cosine of u du, which is easy to integrate. So it's 17 over 2, and integral of this function is the function sine of u and plus some constant c. And finally, this is going to be equal 17 by 2. I'm going to replace this u by the inner function x squared plus 1, and we add this constant of integration c. Now let's compute this definite integral, and the substitution will be the inner function 2x plus 1. Then the derivative of this function with respect to x, this is 2. So du will be 2 dx. And then let's divide both sides by 2. So we'll get half of du on one hand side. This is equal to dx. So the dx factor in the function will be replaced by half of du. So let's do the substitution. First, the integral from integral of the radical of u, and the factor dx in this given function will be replaced by a half of du in this new function, so 1/2 du. Now let's see the bounds of integrations. So first one is 0, and let's see, so if x is 0, then let's see what the corresponding u will be. Well, if x is 0, then this is 2 times 0, and then plus 1. So u is going to be 1. That's the new lower bound of integration of this function, so 1. Now, if x is equal to 4, that's the upper limit of integration of the given function, then the corresponding u will be, let's see, 2 times 4 and plus 1, so 9. So this new integral will be from 1 up to 9. Now the 1/2 is a constant, so we can just pull it outside. So we'll get this is 1/2 and 1/2 times this integral. Integral from 1 to 9 of this function radical is the same as u to the 1/2 du, and we can use the fundamental theorem of calculus to evaluate this. So the constant is 1/2 times, we'll be using the fundamental theorem of calculus. So we'll need one antiderivative of this function, which is 2/3 times u to the 3/2. That's antiderivative of this function, and we want to know what this function is equal to when u is equal to 1 and when u is equal to 9. First at 9. So the 1/2 is just a constant, and then we'll take this antiderivative and we'll evaluate this antiderivative at 9. So that's this number, and minus the same antiderivative, but now evaluated at 1. So this number is 27, and 1 to the 3/2 is just 1. So when we simplify this, we get this is 26 over 3, and that's a definite integral. In this problem, we are given a continuous function f, and we're told that this definite integral is equal to 10. And we need to find this definite integral from 0 to 2 of f composed with the function 2x. So we'll do this by substitution, and we'll let u to be the inner function 2x. So derivative of this function u with respect to x is 2. So du is 2 dx. And we divide both sides by 2. We get half du is dx. So this integral is equal to, well, we'll have integral of f of u, and the dx factor will be half du. So we'll have 1/2 du, and now let's do the bounds of integration. So first 0, and so we have that if x is equal to 0, then let's see the corresponding u. Well, but then u is going to be 2 times 0, which is 0. So u is going to be 0, and that's the lower bound of integration of this new function. To find the upper one, so we'll see if x is equal to 2, that's the upper limit of integration of the given function, then the corresponding u is going to be 2 times 2, which is 4. So this integral is from 0 to 4, and 1/2 is a constant, so we can pull it out. This is equal to, that's the constant, times this integral from 0 to 4 of this function f, but that was given to us, and it was given that this definite integral is equal to 10. So this integral is equal to 10, So this is equal to 10 divided by 2, which is 5. So that's a definite integral.